Daxbot podcast episode number 4. And today we're going to talk about the form, the function, and the design around Daxbot from the mechanical side. And so we have Joe Sullivan Sr., not to be confused with his son Joseph, who was the brainchild behind Dax originally.
He's the man.
But so this is going to be fun to kind of hear about the backstory. It's been fun in the last few podcasts because I've had the chance to ask a lot of questions because I haven't been here very long. I started working full-time for Daxbot in July, and so a lot of the design and things, all the decisions that were made years before I came on board. So it's fun to hear the backstories and all the things that have happened that brought us to this point. So if you could start with just your background and how you came to be part of the Dax project in the first place.
Yeah. So, mechanical engineer. Been doing this for a few years, and mostly working for several automation companies, lots of robotics type of stuff, and I have a lot of experience with stuff that moves in the night, as they say, and so when Joseph came up with this idea, and he wanted to bring it to life, he asked me if I would be interested, and it just so happened to coordinate with the company I was working for was winding down after like 30 years.
Yeah.
So I said, yeah, this sounds like a fun thing to do, and we get along fabulously. So it was just a great opportunity. So he brought me on board, and he'd been working on it, I don't know, a few months. He had brought in a guy that is very artistic and had a lot of talent in that area. Not a very practical sort from my perspective, being an engineer, but very artistic. And he had he had this great suite of software, and so Joseph was doing these sketches, and every once in a while he would even show them. My wife's also very artistic. That's where he gets it. And so he would show that to her and to other people, and they'd talk about, what is this robot supposed to look like, right? And which is a totally different approach than, of course, I would have taken.
Yeah.
So it was a good thing I wasn't there in the beginning. So he and this other fellow worked on it for a while, came up with all these sketches and ideas, and then said, yeah, this is what we want. And so then this fellow started working on making these models. Now, for those who are not familiar with the modeling world, as far as engineering goes, there's kind of two basic types. There's the kind that I'm used to, which in the past have been lots of long, straight lines and cubes and squares and maybe some spheres once in a while. But in this guy's world, nothing is straight, and everything is curved. And he looks at the way light hits an object. He looks at really the interaction with its environment. Right? So in my world, interaction with the environment is make sure it doesn't break.
Yeah.
Because
what you were mentioning automation and things like that. So what types of things in robotics were you involved in for? Like factory floor type automation?
Lots of factory floor type stuff. Not a lot that went outdoors like Dax does.
Oh, okay.
But yet in a lot of actually we're very extreme environments where people can't go.
Sure.
And so some of the reasons for the automation had to do with the fact that it'd be working in poisonous atmospheres, or oddly enough, one of the most deadly places you can put a person accidentally anyway would be in a nitrogen atmosphere.
Oh.
Which is, nitrogen doesn't hurt anybody, right?
Yeah.
But since the atmosphere is made up of almost all nitrogen, your body thinks, hey, this is great, no problem. And it doesn't detect the fact that there's no oxygen. Ah,
sure.
So in a nitrogen atmosphere,
puts you to sleep.
Yeah, you just plop on the floor. So, and I worked in those all kinds of, and that's probably one of the most benign yet very dangerous situations. And other places where people just can't do the work. One of my the last couple of jobs, one had to do with making heart valves.
Oh, okay.
And which that's quite a story, because these people, who I will definitely not name, did not know what they were doing, but they were making heart valves. People weren't dying, at least not that I'd heard of, but they were not following practices and protocols that keep bad things from happening.
Sure.
So anyway, so that's why they hired us.
Yeah.
And I was working on it. And the one just before that was the Microsoft big screen. You've probably seen them. You can put 5 hands on it and do all kinds of stuff.
Oh, neat.
Yeah. Those are actually produced here in Oregon, of all places. So that was kind of nice. But so you can see there's a lot of variety.
Yeah.
Worked on inkjet printers and a lot of stuff having to do with inspection. Also, especially in the early days, made our own robot as needed.
Yeah.
Because we were just starting to make robots and they didn't have just the one we needed, so we would make our own, sort of a thing. So a lot of robotics experience.
Right.
But those robots were very specific in the tasks that they had to do.
Sure, that makes sense.
Yeah.
Rather than, coming back to Dax and a design, no straight lines. Now what?
Now what? Exactly. So Dax needed to have a specific look, and this is really where it all started. And initially, it took me probably a few months anyway to really come up to speed to where he was mentally.
Oh, yeah.
And my first thought was, delivery. Looks like the Mars rover with a pouch. It's just, how hard could it be? So, what Joseph needed to do, what his real vision was to do something that would be almost kind of accepted, not just sought after, something that would be workable in an everyday environment.
Yeah.
And so, because of that, there are some things that we also didn't do. Like I'm used to working with straight lines.
Yeah.
Joseph, I said, well, we need to know where we're going. We'll use LiDAR. No. Not going to use LiDAR. LiDAR is, in a sense, it's too easy. Well, if we're not going to use LiDAR, how are we going to get around? We're going to take a look, and then we're going to figure out where things are.
Yeah.
Just like a person does. Like a person does. Well, we could do that, but but then there's all these other technology. No.
Yeah.
We want to use the same. We want it just like the eyes. Well, turns out that what's really behind that is he wants. In fact, I think he's the one that coined the term Cani-morphic.
Right.
Right.
Yeah.
As being kind of dog-like or something, but alive.
Yeah.
Is the point. And so the deeper you dig into the whole backstory of this, the more you find out that he wasn't looking for a dog with a pouch either.
Right.
It definitely had to be a robot.
Yeah.
But looking for something that would interact with people. And in order to interact with people, you need to, and not talk, for instance, you need to be able to give the same kind of cues that a person does, right?
Right.
So, consequently, when a robot needs to cross the street, it can come out to the edge of the street corner and sit there and
Yep.
sit there. Yeah, yep. Or it can look around, it can make eye contact.
Right.
And the operator that would be on the other side of this to make sure that we keep the human element involved would be able to be like he's there. It would be just like he's there. So early on, one of the things that we did was we brought in one of Joseph's kids, and we made a little foam hat, and we put a cell phone on the top of the hat.
Okay.
Glued it on top of there, and then set up the software so that we could do an analysis of how the kid looked around, and what we're looking for are angles and accelerations, and to actually figure out what's natural, because we didn't want to do anything that wouldn't be natural.
Right.
So that gave us the parameters for Dax being able to look around.
Interesting.
Yeah.
And even more, I would imagine, even more childlike, right? Versus an adult I mean, having little kids, I mean, they can bounce off walls and things, right? So
Right.
Yeah.
So it gave us a lot of the motions, and then for the Cana part of it, we're looking at, there's actually been studies that'll tell you how far a dog will tilt his head
Oh, interesting.
when he's curious, like this. And so
funny.
we got into the research and found out just how dogs do it,
Yeah.
and said, that's what Dax needs to do. So all the mechanisms are centered around this ability to communicate non-verbally,
Yeah.
and mostly using his head. And then, of course, his eyes, too.
Mm-hmm.
The eyes were, at least for us, a bit challenging at first. I mean, you look at the eyes now and you say, oh, makes sense. I mean, how else would you do it? We did some weird things in the beginning, trying to mechanically simulate some of the things. Is Dax smiles with his eyes.
Like mechanical eyes? Or
Yeah, we even got some mechanical eyes
Really?
that were made out of some fiber optic type material that had the little motors that would turn, and it would change the shape of the eye and around, and then you could rotate it and stuff. And also used one of the world's smallest projectors and stuck it inside
No
the
kidding.
head,
That's crazy.
and that got pretty hot.
Yeah, I can imagine.
Yeah.
Yeah.
But eventually, we developed basically the LED array that goes in the head, and one of the challenges they also don't think about that is LED arrays are supposed to be flat,
Yeah.
right? And when you look, you can see this one isn't flat. So it was one more thing yet that we needed to figure out how to do. So how do you make a circuit board that's not flat? Well, it turns out other people were doing it. So it wasn't as though we reinvented the wheel totally, but we needed to get thousands of LEDs and it needed to be on a curved surface. And you couldn't just use bright white light, right?
Right.
So we did lots of tests with Dax's eyes outside and with color filters. We've got over in one of the engineering shelves, we have a book of filters, sheet filters.
Okay.
And you can place that over a white light or whatever.
Yeah.
And in this case, we placed over some the LED arrays until we came to just the right color for Dax. And because he needed to be friendly.
Yeah.
Right. If you're a fan of the movies, you'll know that most of the time the bad robots have red eyes.
Yep.
Yes, everybody knows this. And so ours robot was not going to be one of those robots. And yes, there were the jokes about what if he was packing an AK or something like that. And every time we went there, we went the opposite direction and said, no, Dax is not that robot.
Yeah.
He's the robot that he's going down the street, some kid puts a sack over his head, and everybody thinks that kid's evil.
Sure.
Because he's tormented Dax. Right?
Yeah.
They feel sorry for Dax.
Yep.
So Dax, and which is one of the Asimov's rules of robotics, is that you won't do any harm.
Right.
Right. So we took that pretty seriously, and we wanted to go a step further. So another thing that we considered as well is the experience of the people that do drones. Now, it wasn't that many years ago when they first started coming out, and at Christmas time, all the kids had these little copters that you could fly around in the living room and annoy people. And, then they got bigger and they got faster, and people started doing things they shouldn't do with them to invade other people's privacy. And you know what? You don't see drones around anymore. There are still some places, I think if I remember correctly, that you can do that. You can still have them pretty freely in places in Australia.
Yeah.
But in the U.S., they got highly regulated.
Yeah.
And the reason is because they had a bad start. And Joseph did not want to have a bad start to Dax.
Yeah.
So if you take the robot and you put him out on the sidewalk, and if he's even in the way on the sidewalk, then people have a bad experience with him.
Yeah.
So that was not going to be for us.
Yeah.
Also, Dax is basically the width of a stroller.
Okay. Yeah.
Because we're looking at what would be a good size for the sidewalk, and I've seen examples of other people trying to achieve the goal of delivery, coming up with some pretty big bots.
Yeah.
And of course they hold a lot.
Yeah.
But people don't like them when they're in the way.
Right.
So we had a limit to the width of DAX. We also kind of had a limit to the height of DAX. Mostly that had to do with the DAX being friendly.
Yeah.
Right. So even the shortest of people looks down on DAX.
Yeah.
And so DAX is totally not only anyway not intimidating.
Right.
Right. So that's kind of where a lot of this started, is in me getting to understand that this is the direction we needed to go in.
Yeah.
And I wasn't initially convinced that there's so many practical things we can do, and we just need to get them out there. But it was evident from the very beginning that we really needed to do it right.
Yeah.
And that there was only going to be really one right way to do it.
Mm-hmm.
So we started making DAX, and there were some challenges for us. The getting all these shapes made meant that we needed to invent some technologies that other people have been doing.
Yeah.
So that DAX could look just like the one that they envisioned.
Mm-hmm.
So DAX does look like the one they envisioned. Not very many flat surfaces, maybe like one or two on the whole robot.
Yeah.
And so every time something needs to be mounted to the inside of DAX, I need to, you have to make some adapter.
Yeah.
With a complex shape, you don't just say, well, I want to, make a little bit of a curve, a little bit of a straight line. You have to have the software add and subtract from other surfaces, so you get matching surfaces. Otherwise, things don't want to go together.
Right. Yeah.
So it became a much more lengthy process than I originally thought it would be.
Yeah.
Yeah.
I can imagine.
But so we got the and then there was also the there's a lot of thermoform plastic on DAX.
Mm-hmm.
One of the things that we ran into was that we were not able to find any thermoformers that would do clear plastic.
Oh.
And DAX has to have a part of his head has to be clear.
Yeah.
Where you see the eyes, right? So that was a process that we did end up developing, and that we still end up doing today because nobody's willing to do it.
Yeah.
And to be fair, when you say clear plastic, people think that any kind of a mark will make it not work for us.
Yeah.
Right. So we didn't have quite that high a demand on the clear plastic, but we needed to shape it and keep it clear. And so anyway, we just developed that ourselves.
Yeah.
We ended up needing to do some thermal forming, so we did the typical YouTube thing where you go out to Home Depot and you buy some plywood and a couple of heaters and you stick them in the bottom of the box, and you get your stopwatch out and you do all this crazy stuff. And all the while though, I was looking on Craigslist just in case, and one day a thermoformer pops up on Craigslist. It's like, really? This is exactly what we need.
Yeah.
And it was only like $1,500.
Yeah.
And it was one of the best deals we ever did. But it made it so that it definitely took us way past the first level that we were doing on thermoforming and stuff.
Blow dryers from
Yeah, like blow dryers, exactly. So we did that. But I like to talk sometimes about the Uncanny Valley.
Yeah.
Right? And it always requires also a little bit of history behind it.
That's what I was going to ask, because
what is,
most people don't know. I didn't know
what does that mean? The Uncanny Valley wasn't really discovered, if you will, until computer graphics got to the point where you could start mimicking human face. And the Uncanny Valley is that point where you go from, you start with, everybody sees Mickey Mouse, and nobody, well, back in the 30s, he was kind of a disturbing character. The modern Mickey Mouse is fairly friendly. He's come a long way.
Yeah.
But he's obviously not human.
Yeah. Right.
And so there was a point in time, just pre-2000s, I think it was, that graphics started getting much better.
Mm-hmm.
And they started approaching being able to look like a human face. And there were some movies that came out at the time. There was the Polar Express, I think, was one of them.
Oh, right. Yeah.
And you look at that and you say, is this just a makeover at the top of the guy's face, or what's going on? And
Yeah.
people started, it was getting to the point where it would be disturbing to people because they could tell it really wasn't. I mean, you can tell on Polar Express that's not a real person, right? Unless they've colorized him or done
Yeah.
something weird, that it's generated somehow. So if you get too close to what a person looks like, but you're still not there, they call it the Uncanny Valley, because there's something built inside of us that tells us this is wrong.
Yeah. Something's not right.
Something is not right. And so that was one of the things that we also wanted to do, is stay away from that in the robotics world.
Yeah.
So there's some great movies. One of my favorite in the last 20 years would be iRobot.
Yeah.
With Will Smith, right? And he has a great robot with a face, and it talks, and they interact with it. And the main character doesn't like him for his own reasons.
Yeah.
But it's one of those things where you're being forced to make a decision about this face,
Mm-hmm.
and whether or not whether you interact with it cold like a machine or warm like a person,
Yep.
or what you're going to do. The idea is that we would never go there, okay? And so what we wanted to do is something more along the lines of well, let me put it this way. What we wanted to do is to be able to show Dax to a 6-year-old, and 6-year-old come up and give Dax a hug
Yeah.
without even thinking about it,
Sure.
right? And
That's so funny you say that, because that happened. I was doing a demo at a university up the road a ways, and I stopped kind of halfway through, and somebody pulled over, and he had 2 kids. One was 6 and one was 3, and yeah, 6-year-old was doing foot races with Dax, and then gave him a hug at the end. So, yeah, no prompting, obviously, right?
yeah,
So it's pretty crazy.
and that's the goal,
Yeah.
right? So we wanted a product where we put him out there and people look for him.
Yeah.
They come, they want to interact with him, and Dax interacts with them.
Yep.
And they have a very positive experience. And we want that experience to be genuine. There's actually, when he's interacting directly with people, we have a person involved to make sure everything goes well.
Yeah.
And and that goes for also crossing a sidewalk, sort of a thing. It's
Yeah. Crossing the road.
yeah, crossing the road, right? Thanks.
Yeah.
Which is, if you're on the operator side, it's rather an intense time.
Yeah.
But it means that when you're so when you come to the crosswalk to cross, that start looking both ways. In this town, a lot of people just keep going by, but in the early days, we had people stopping.
Oh yeah.
Yeah, and so we'd have traffic stop going both ways.
Yeah.
And there would be people looking at him.
Yep.
And Dax would look back, and then he would cross the street, and they just about applauded.
Yeah.
When he did that, right?
Right.
Now around here, it's a lot more common to see Dax.
Yep.
So there's people that are very, very chill about him doing that.
Yep.
That's exactly what we've been looking for with
Yeah.
Dax, right? Something that people want to interact with, and not in that uncanny valley.
Yep.
And people want to have him over for birthday parties,
Yeah.
right?
That's true. We get a lot of those phone calls. Yeah.
Yeah, I bet.
Yeah.
Yeah. So anyway, yeah, Dax is a celebrity pretty much wherever he goes.
Yeah. It's pretty neat. And yeah, because again, I get the chance to do demos in different. I've been to a few states now. And same thing. Like anytime you're showing up in a new place, Dax causes a scene. Not in a bad way. I don't think he's caused any traffic accidents, but people will pull up to the side of the road and what is that thing? And it's kind of neat. And to the interesting thing, like recently, I've actually had people send me some videos and things of robotics is advancing, and so some of the the Uncanny Valley thing where there's some robots, even just the facial expressions and things like that, it is creepily human-like, and so what's interesting from my perspective, because I don't have a background in robotics at all, so from my perspective, I look at that, I'm like, well, that's really neat, but it doesn't actually do anything. I mean, there's the famous Sophia robot, who is a citizen of Saudi Arabia and things like that. Pretty neat, but not actually helpful, right? It's not actually doing anything.
Yeah.
And then you have the other side that I've seen where, there's some big robots that are delivering stuff on sidewalks, and some of them essentially hog the whole sidewalk, and, these aren't train tracks, right? This is a pedestrian space, so we need to respect that, which is back to that point. So it's very functional, a lot of straight lines, right? A lot of, capacity, but it's not friendly, right? It doesn't have that aspect. And Dax is unique from the perspective of both have actually come together, and it is not just the form where it's really good, attractive, people want to interact with it, all those things, but it's also functional. So can we talk about that side too of, because yes, there's robotics teams. Anybody could build a delivery robot, in my mind now. There's enough, high school students that could build a delivery robot, do it in a box and some wheels. So that's not difficult. But having the idea to do both is kind of unique. And so, so what was that like as far as like, here's the function that we want Dax to be doing?
Yeah. So functionally, of course, he needs to be able to go places.
Yep.
He needs to carry a load. And one of the things that we try to figure out is how fast should Dax go?
Yeah.
Right? When he's on the sidewalk, how fast should he go? And my wife has been, in younger days, was a runner, and now she's a walker. And turns out that when she does her competition walking, she walks at about 4 miles an hour.
Yeah.
So that was Dax's top speed.
Yeah.
Yeah. And going around any town you go around these days, you'll find that there are a lot of ADA access places around. So ADA in fact, I think I spent an entire week just doing ADA research, because there's a lot of money from the federal side to retrofit sidewalks and entrances and all kinds of things for ADA.
Yeah, and ADA is the American with Disabilities Act. Right?
Disabilities Act,
yeah.
Right. So allowing people that have some disability to go places.
Yeah.
So we figured, well, that's a great place for Dax to start. All of the ADA, so Dax is designed to go up and down ADA ramps and fit in all the ADA places, and so that was another thing that kind of helped to drive the design.
Yeah.
And then the tracks, people like to ask me about that sometimes, and the tracks are there's an obvious good side about tracks, and that is you can take them just about anywhere.
Yep.
And in the town where we make Dax, there are some great sidewalks and there are some really bad sidewalks.
Yeah.
And to be fair, it's not all the town's fault. I mean, the people are responsible for the sidewalk in front of their place.
Yeah.
Right. And the town's very nice about not forcing them to do things.
Yeah.
So that makes a great place to try out Dax.
Yep.
And so we have sidewalks. Some of them, you step up quite a bit, or they're crooked, or they're just parts that are sections that are missing, and so having tracks makes it so that we can traverse those spaces very easily. We can go across some pretty big gaps.
Yep.
And if we go slowly, we can climb. And one of the downsides about tracks, though, is, especially our tracks, is they're very grabby. So in the early days, we had problems with Dax going too far, and he'll climb up your leg if you let him, or he'll climb up a post if you let him. He'll climb up a wall until he falls over anyway.
Right.
So there's that part about Dax, and then there's the being able to turn with tracks.
Yeah.
So tracks are harder to turn with, right?
Mm-hmm.
And we needed to have tracks that also wouldn't mar an inside surface. So there was some research that went into the materials, and then how do you construct the tracks so that they have just the right amount of contact with the floor, but not so much that he can't turn very easily.
Yeah.
And so the shape of the tracks turned out to be, well, the original shape turned out to be very defined by aesthetics.
Yeah.
But in the minor details of the tracks, as far as where the rollers go on the inside and things like that, and whether they should all be the same or different, that took actually quite a bit of work and trial and error. Setting them out to places, setting them indoors, and walking behind him, making sure he's not making a mess.
Yeah.
That sort of thing.
Right.
But so we ended up with some tracks that do all of these things. They actually do it really well.
Yeah.
And we see, and on top of it, it was kind of a plus. We see very little wear on our tracks.
Yeah.
Over time as well. So once we got the tracks figured out, it turned out to work really well for us. We can even one of the more recent software updates allows us to basically spin on a dime.
Yeah.
With the tracks. And we there was a time where if you tried to do that, Dax would spin and one of the tracks would pop off.
Oh. That's not good. Yeah.
No, that's not good. And you probably haven't heard of that happening.
No, well, it's been a while. Yeah.
It's been quite a while anyway.
Yeah.
So just the tracks, and of course they had to be black.
Yep.
That was one of the aesthetic things, and so the spacing of the teeth on the tracks and the shape of the tracks, that was all something that was handed down, given to us, and then we had to make these little tweaks back and forth to make them functional out there on the street.
Yeah. So one thing I don't think I've asked anybody. So even yesterday when I was up at this university, and there's all these college students that were, because Dax is a celebrity, people have never seen anything like this, and so they're all crowded around and taking pictures and videos and things like that. And without any prompting, one of the gals that was there said, "Oh, he looks like Wally. Wait, he looks like Eva. He looks like Wally and Eva had a baby." And it's so funny because I hear that a lot of times from different people, and it's kind of a funny thing. Was that actually like part of the thought, like we watched Wally and we're gonna try and make this hybrid, or did it just turn out?
It is very what resemblance there is definitely a coincidence.
Okay. Yeah.
Dax was the shape and size of Dax was all strictly a creative effort.
Yeah.
And I'm sure that all of our creative efforts tend to be influenced by our experiences.
Yeah.
And yes, we've seen it, but we were not interested in doing one of those in a way. But we do get that comment a lot.
Yeah.
Yeah.
It's really interesting.
Yes. Yeah. And it has and it goes further than just the looks.
Yeah.
Right? Because the robots in the movies, those two robots, have a relationship.
Yeah.
Which is kind of strange for a robot.
Right.
And Dax relates to people.
Yep.
So it's not that far off the mark. It was never intentional.
Yeah.
But and Dax he has the right colors. He has tracks.
Yep.
Like Wally, and so it's like you said, we hear that one quite often. Yeah.
Yeah, it is pretty fun. Yeah, especially little kids that like Wally. So can we talk about the cargo space and things like that? I mean, even I heard, and you can correct me if I'm wrong on this, but even to the friendly piece, and with that drawer that comes in and out where the cargo is, and if that drawer is closing and a kid starts getting his finger in there's enough resistance that it knows to not crush fingers and those types of things. So yeah, can you talk about that design?
Yeah. Actually, there's a critical number having to do with the sharpness of an object and the force that which you can exercise on that sharp edge and a person's hand.
Ah, yeah.
Okay. So which is something that I carried over from my time in the automation world.
Yeah.
So Dax is limited to under 5 pounds, and it's really simple. He stalls.
Yeah.
If you stop it.
That makes sense.
Now there are some other things that go on with Dax too. The drawer couldn't just open.
Right.
Right. In fact, those were my exact words at one point. The drawer can't just open. No, the drawer has to present itself.
Yes.
So you notice that as Dax's drawer opens, it comes forward and then it tilts forward.
Yes.
Right, because it's welcoming. So and that was just part of the friendly allure that we wanted for Dax. So in fact, I've got a kind of a funny story associated with that. In the early days when we were running Dax around and basically showing them to the neighbors, if you will, which is basically just the people in town, there was some folks at a local bank that wanted some donuts.
Okay.
And so the manager at the bank called the donut shop and ordered the donuts, and Dax went down there and picked up the donuts, made the delivery, and the drawer opens up, the guy takes out the donuts, and everybody's standing around and having a good time and all this sort of thing. And before Dax can shut his drawer, the manager comes over and gives it a push.
Okay. Yeah.
We had never thought of doing that, right?
Yeah.
Because that is one of the problems you have with engineers, is that they know how they've designed it.
Yeah.
So they will treat it just the way they've designed it, right?
Yeah.
Now, it's natural to maybe, and we did this, to put something in the way, put your hand in there so when it's closing, just different things like that. But we just never thought of pushing it. So he pushes it, and the mechanism goes over center in the wrong direction.
Oh.
So now Dax can't close his drawer.
Right.
But that was the value, that was one of the many times that we saw the value in taking him out into the real world and trying him out, right? Is people are really unpredictable.
Yeah.
And things that we never would have thought of doing, they do. And then we bring them back and say, well, this is going to happen again. What are we going to do to stop that? And so,
right.
And it was just a little bit of a redesign with the mechanism anyway. But just fun little things like that all over the place.
Yeah.
And then there was taking Dax out on the rain.
Sure.
So Dax is like the mailman through hail and snow and sleet and all that. He needs to deliver.
Yeah.
And he has the tracks, and we have the weather. So we get, we're very fortunate in a way that we get snow here. We get lots of rain here. We get plenty of sunshine. We get up to, I try to remember, we got up to 108 last year, I think it was, which is not Phoenix.
Yeah.
But, so it gives us quite a broad test base for Dax, especially if we're willing to wait for the seasons to come around.
Right.
And so in the early days, we found out where we needed to add fans when it got too hot, and what to do with the water when it would start raining. And the bottom line is that Dax makes dry deliveries, and he can go through any piece of any weather you throw at him pretty much. There's times where he may get lost when he's trying to be fully autonomous, because if you take all of the markings on a road and you cover it with 6 inches of snow, and all of a sudden the only thing that's left are the trees and the houses and some cars that are mostly buried, then that's kind of a different scenario.
Right.
But as far as being able to go any place he wants to, he can. And it would be pushing the limit, but even in the scenario I described with all the snow, he has multiple ways that he can recognize and go places.
Right.
And because of that redundancy, he's still able to go most places, but it's probably not wise to push it all the time.
Yeah, that's fair. I was joking with a friend from Montana and was saying, these tracks, if you just put a snowplow in the front of this thing and clear sidewalks for Grandma, it's going to be great.
Yeah.
Because I know that's one of the things that Joseph also sees, that his vision was, a kind of a utility service robot, delivery happens to be the first application to put him into, and then he has this idea of there's so many other things that robots can be doing for people. So maybe not this design specifically, but there are going to be other designs and things down the road. What do you see the future of maybe this version of Dax? What are future things that you see that would be helpful, that would make it better? And then what do you see outside of this, form function of Dax? That could be a second form that you and Joseph have talked about.
Yeah. Well, Dax, aesthetically, we don't want to violate that what we've done.
Yeah.
Okay. And there's some variations we can do on Dax. For instance, Dax has a very cute profile with these tracks kind of hanging out there, and then there's the body.
Yeah.
So without taking up any more of the sidewalk, Dax could be wider in his delivery area.
Oh, sure.
With the same track footprint.
Yeah.
So that's one of the things we could do. One of the things that I haven't mentioned that we have done is do climate control in his delivery.
Right.
So the heating was the first thing we did, being able to keep the payload at room temperature, or if it's like food that wants to be hot, or we want it to be hot, like pizza, then you could put it at a higher temperature. Right?
Yeah.
So we're able to do that. Cooling was a little more complicated, and looks like we've got that taken care of now, so he can do both.
Yeah.
And there are a lot more opportunities than just food delivery for doing that.
Right.
There are definitely times where, especially in like medicines and stuff, that you and other things that need to be temperature controlled, that you would want to know, instead of just putting it in a box that has some dry ice or some ice in it.
Yeah.
And you say, and so I have this thermometer that says that this was the high temperature for the last week, or
Yeah.
the low temperature for the last week, that you actually have a record of the temperature the entire time.
Sure.
And there's industries, specifically medical, that I've been involved in, where that's what they're looking for.
Right.
During, like with that heart valve project that I worked on, they wanted to know what the temperature of the fluid was all the time.
Yeah.
And they keep a record of that for every single valve that they make. And that's an important thing when you get into that industry. There's a traceability requirement. I won't quote the number, but that's a big deal in that industry. So having temperature control also opens up the possibilities into, like, especially the medical industry, as I see it.
Right.
Yeah. So we're doing that. There's things like opening and closing doors. We have a design for opening doors, and that we've ran some successful tests on, and it's kind of cute when he does it. He does a dance.
Yep.
And but he manages to open up a door, and it's one of those things that I could probably not describe to you very well. You have to see it to believe it.
Right.
How it all works. But opening doors is something that we have also looked at. Let's see. The other things that we've looked at are different ways to. We've been asked a lot about increasing his speed, which we've pretty much rejected out of hand, because we don't want to go back to competing with people on the sidewalks.
Sure.
And one of the things that, in fact, along those lines that we've considered is, what do you do on a very, very busy sidewalk, like a New York City sidewalk? And because Dax is short.
Yeah.
And on most sidewalks, it's Dax is just another curious pedestrian running around. But if you get to a density in which Dax is not visible, because there's people in big overcoats walking up there, and Dax is coming the other direction, and then they part at the last minute for Dax to go through, and the guy the guy was right behind them ends up running into Dax.
Yeah.
So in those particular scenarios, we'll have to do something to give him better visibility. And so where we've resisted, like, putting flags on because they look kind of ridiculous,
Yeah.
there could be situations in which that would make him much definitely more viable. And it's very simple anyway.
Yeah.
Yeah. There's things we're looking at for increasing range. Everybody wants stacks to go forever on a single charge.
Yeah.
And one of the things that we decided to do from the beginning was to make the battery easily replaceable. So in just a few seconds, you can push a lever, drop the old battery out, put the new battery in, he's on his way.
Yep.
And that means that Dax doesn't have to sit for hours being charged, but can just have new batteries. So that was the first thing we did, and that allows Dax to have basically run 24/7. He just needs more batteries, right? So it's kind of like your drill from Home Depot with the Ryobi batteries in it or something. You just need more Ryobi batteries to stick in there. But if you wanted him to go further, like say for security purposes, so Dax is able to see at night, and that was kind of a fun project too. But he sees actually pretty well in the dark.
Yeah, I was driving him the other morning.
Yeah.
6 a.m. I'm like,
yeah, it's pretty
looks
cool.
good. Yeah.
So, excuse me, in a security application, what he would need to do would be to, say, tour a plant.
Yeah.
And do that all night long. And his feet don't get tired, but he does use battery.
Right.
So there are ways to extend the battery. For instance, in a security application, we're not so concerned about payload.
Yeah.
As far as right now, it's some people get surprised because when Dax opens up, you can see he's mostly payload space.
Right.
He's not huge, but what he's got is mostly payload space.
Yeah.
So that payload space could be used for more energy storage.
Yep.
And the other thing is the chemistry that we use for the batteries. So the battery packs that we use are lithium iron phosphate, not lithium ion, lithium iron. And they're notoriously quite safe. So the stuff you've heard about batteries catching on fire and all that sort of thing, it'd be very difficult to do with these battery pack.
Gotcha.
So, but you do pay a cost. The lithium iron is good for more charge and discharge cycles. Okay. But it also has about half the capacity.
Oh.
Yeah.
Yeah.
So just by changing the chemistry, we can go twice as far.
Yeah.
Yeah. So, but that would be like it'd be a fairly straightforward thing to do if we had a customer who was really interested in having us do that.
Yeah.
So, what does that mean? It means that instead of changing the battery, I guess if Dax is running continuously, you probably know better than I. How long would he go?
Probably about 3 hours.
About 3 hours, yeah.
Yeah.
So the difference between 3 hours and 6 hours,
yeah,
is the kind of thing you would get.
Yeah, that makes sense.
Yeah. we have done some testing with bigger battery packs for duration, and in fact that's how we ran a 5K or walked or
tracked
yeah. 5K. So he was, as far as we know, he was the first robot to do that, and I know there was going to be an application to the Guinness Book of Records, but seriously, and I think there still could be, but yeah, he finished his 5K, did well.
Yeah.
He didn't tire.
That's good.
But yeah, our original battery packs were very conservative in that we wanted to make sure that he would run a long time.
Yeah.
But and for that we did use the lithium-ion battery packs, and we were going since we weren't doing deliveries exactly often.
Yeah.
We were running lots of tests, so we would run Dax for a couple of weeks in those days on the other pack.
Wow.
Yeah. But so there's some stuff we can do with the batteries as well.
Yeah, that's neat. So with do you see a whole different design? Like, do you see Daxbot as a company moving to like humanoid robots or anything in the future?
I think we've got a great thing going right now.
Yeah.
And it's there'd have to be a really compelling reason to do that.
Sure.
Now, Dax has some very cool technology that allows him to be operated remotely, and we're talking about like one of the early tests we did. We had a fella in Texas, and we put the technology into an RC car about this big.
Nice.
And he was able to navigate the RC car through tracks and tunnels and that sort of thing from Texas.
Yeah.
Real time. So we have the ability to interact in such a way that and see and in other words, it could be applied to other things like maybe a lawnmower.
Oh, sure.
Or anything that moves.
Yeah.
We should be able to do well with automating mundane tasks.
Yeah.
And you hear the term freeing up people for things.
Yeah.
In our case, where there's some truth in that, more than that, we're involving people more. As you know, for robot operators.
Yeah.
Right. So that is one of the things that we are doing, and right now we operate somewhere between 1 and 20 robots per person, or are supposed to be able to anyway.
Yeah.
And depending on how busy things are, we may often only have one person, but it's a person that's behind it somewhere.
Yeah.
And that person can tell the robot, well, you go from point A to B, and when you get to that place where you're crossing the street, you wait for me, and I'll get you across the street.
Yeah.
And the robot looks both ways.
Yeah.
And it's all clear, and he goes across the street. So.
Yeah, it's really interesting because there's a lot of people, even legislation where it's specific, like you have to have somebody overseeing this at all times, and so it's kind of obviously the broad spectrum. You have those that are more the engineer types, and they want to know all the nuts and bolts and things, and so I'm sure there's hopefully there's a mechanical engineer that hears this, they can empathize and be like, no straight lines at all, okay. And then you got the other extreme, which is where most people are at, and it's just magic, right? It is an entity, like it's its own thing and its own personality, and which is kind of unique. But yes, we hire people that essentially are taking care of the robots as they're in transit and when they get to streets and when they interact with people, and making sure that the experience that they have on the other end of Dax is positive.
Mm-hmm.
And it's kind of going back to that the same thing you were talking about, like making it personable so that people have a good experience. And the funny thing is, even myself, because I know the guys that are back there taking care of them, and I know how they're built and all this stuff. But it's amazing. I'll be walking on the streets in town here, and I'll see a robot coming in, and I'll just wave and say, "Hey, Dax," just like it's another person. And it's amazing, like this psychology. I don't know, like behind it, but it was pretty neat to see the the vision that Joseph had, that it was it actually has come to life, and it's doing actual work for actual people in the space, and it's really well received. So.
Yes. Yeah, he's loved everywhere he goes, and sometimes too much. We had, I can tell you another story about, he has a button on him, on the top. Yeah, you look around and you'll see that Dax only has one button, and we make good use of that button. So it was, again, from my automation experience, that I knew that we had to be able to, you have to be able to stop Dax.
Sure.
In case something goes wrong, right? And of course, in the early days, things would go wrong.
Yeah.
But we just don't seem to have, and we don't seem to have those situations come up very often anymore. It's very seldom. Well, we took Dax to a baseball game, and there was a local team playing another team, and Dax was outside of the stadium, and there was a bunch of kids who had come there to see the game who didn't want to go inside the stadium anymore.
Oh.
They wanted to stay out and play with Dax, right?
Right.
And so you can imagine Dax is just kind of out there, and he's looking around, and he's doing his thing and smiling and all this. and just mobbed with kids.
Yeah.
And so some kid took his finger and pushed that button. And in the early days when you do that, Dax resets and goes down.
No.
And he's doesn't do anything for like several minutes.
Yeah.
While we reboot all of his systems. And that's where we learned that we needed to do something a little different.
Yeah.
So Dax, so there's in the industry there's more than one function that you can have for a button like that.
Right.
Right.
Yeah.
One of them is an EMO, emergency motor off.
Okay.
And so I would consider that button is basically our emergency motor off. And what it does is it disables electrical energy to things that move.
Right.
So that if there's a problem, those things don't move anymore.
Yep.
For now. And I'd have to check to remember what the current sequence is for that. But Dax no longer dies when you push that button.
Yeah, he does not.
But he does stop whatever he's doing.
Yep.
And he doesn't lose consciousness.
Yeah.
And when they let go, he can start interacting again.
Yep.
But and what it does, of course, it also notifies the operator, so that if there is a real problem, that the operator can do something about it. Right.
Yeah.
So that's why we have that button, and it's easy to see on the top, and you learn a lot by showing it to kids.
Oh
and
man, yeah. That I would say that is to the chagrin of the operators. They the kids find that button, and that he's driving down the sidewalk, and they hit the button, and the tracks stop moving. That's what it's designed for. But then they have to wait, type in the command to get the the drive command back in. Like, no, it's just kids. There's nothing wrong.
Yeah.
So the button gets it. Yeah.
Yeah.
My kids, but that's fantastic. Was there anything else? I know we're wrapping up. We're getting close to being done. But is there anything else that you can think of that would be helpful for people that are just wanting to learn about Dax and things like that?
Well, as is always said in these sorts of situations, you can go to the website, right? But honestly, I would encourage anybody who's really curious just to they can even come to our little town and experience Dax.
Yeah.
There are people and there are actually people that do that.
Mm-hmm.
There are people that do not live in the service area.
Yep.
Who come into town and have Dax delivered to the park or wherever they happen to be, and they drove 30-45 minutes to come to the park and
Yep.
be delivered by Dax. So that'll tell you that it is an experience.
Yeah.
And it's one that especially the kids enjoy.
Yep.
And the adults like us.
Yeah.
As well. So I would encourage anybody who it'd be practical for to come do that. Just come into town, go into maybe one of the restaurants or something, and say I want to place an order with Dax. We just call and say, where does Dax deliver? And
Yeah.
sort of a thing. The Dax experience is something not to be missed.
Yeah. It is pretty neat. And yeah, we've had people come in that were even looking at using Dax as a service, and they've come in from Los Angeles and Spokane.
Mm-hmm.
So it's just interesting to see. Yeah, people want to come and have the experience themselves. So
Mm-hmm.
it's fun for me to be able to take Dax other places and bring that experience other places too, which is kind of neat. So.
And then one other that kind of occurs to me from time to time is I read an article a couple years ago about a lady who is stuck in a wheelchair, and she is at that time was quite the advocate against sidewalk robots. But and so I read the article and the things that she was saying, and I realized that Dax is none of those things.
Right.
That she dislikes in a robot.
Yeah.
And I kind of wish I'd almost like to go back and find that article again and maybe get a hold of her.
Yeah.
Oh, I should also mention that not that long ago, I guess it was probably maybe even a year ago, that we also were taking Dax to places. We visited Home for the Blind.
Mm-hmm.
And also some people with wheelchairs, and so we've gone out to try and get feedback from all kinds of people. And if we could find this gal that I remember reading the article about, I think she would love Dax.
Yeah.
I think she'd have a change of heart.
Yeah. Well, thanks for taking some time out of your day to do this with us. And
My pleasure.